Hi, so my name's Ahmad Judah. I'm with Alice Corp Engineers, and we're representing Siemens here in testing the double redundancy to redundant Y switch ring to the G220 network topology.
I'm Thomas. I'm a hardware support engineer for Atlas.
Yep. And behind the camera, we have Jacob.
Yep, I'm Jake. I am also a hardware person.
Do you want to go around the room?
Yeah.
Yeah.
Hey everyone, my name is Mohammed Sultan. I'm working for Global Team, INC engineer. This is my first month with Micron, so I tried to come up with the idea with pictures to use Profinet over hot wire and future projects for Micron. So I'm glad to work with Micron, especially with Android Picture and Indra. So we try to come up with the idea, of course, to reduce the costs, in the projects instead to use traditional hot wire. So that's why we work with Siemens to come up with the ideas, especially in networking topology. So this is what the show is. So hopefully we can come up with all the team, their recommendations, their references to use this idea to implement it in Micron projects.
Hello everyone, my name is Shady Olamfemi, and I am civil engineer with Micron here in Boise.
Back over to
Alan Nichols, I'm Instrumentation Controls in Boise, facilities, and I'm invited us to come see your demonstration.
Hi, I'm Victor Clark. I'm an INC engineer for the Clay project in New York. Glad to be here. Randy Fulton, INC Boise.
Mitchell Peterson, TD Facilities INC Supervisor.
Alex Starr, INC Technician at Boise.
I'm Brian Taylor. I head up semiconductor for the U.S. for Siemens.
James Boyd, Global Team for Electrical side.
Bill Grandwater, skate engineer for Micron Boise.
Darren Wood with Siemens, the account executive for Micron Technology. Been doing that for about 13 years for Siemens. Worked with Micron for really off and on through different career paths for about 30 years. So a native Idahoan and growing up with Micron, so I'm pretty excited about it. So we appreciate you guys coming here this morning and going through this OT network testing with the VFD. Siemens has been doing Profinet control of the drives for since we released Profinet, which is over 15 years ago. So it's a pretty standard, industry accepted technology. It's a technology that we use not only for the I/O that is going to be implemented in ID1 in redundant rings similar to this, but also with drives and other connected Profinet devices. So you can even get into instrumentation, those kind of things. So like I said, multiple nodes that are installed industry-wise, not only in semiconductor, but also in general industry. So we really appreciate your time today, and I think Ahmad's going to go through the physical layout of this and what we've architected. It's in your agenda, kind of the architecture that we have, and then we'll go through the different segments and test those segments. We've got actually a testing document there. If anybody wants to follow along and make notes to it, I'll go keep an electronic copy of it, and you can compare notes and make sure that everything's, we're all aligned up with the results, what the expected results and what the actual results are. So, and feel free, if anybody has any questions, how the system is reacting, what the expected reaction is supposed to be, and how it's reacting, please speak up and we can go into detail on that. So.
also donuts and cinnamon rolls and coffee.
Yeah,
Coffee. All right.
Guys, I'm just a little bit of a little expansion for me. We have a dying set up in Vancouver. We've done all the testing. There is some additional documentations that are floating around. There's one right there. We'll make sure we send electronic versions to everybody that's here. What we believe we understand is the needs of the semiconductor industry. We encourage you guys to provide some feedback on things that we've tested and proven for the other folks in the industry as to what our drive can do. If you guys go through there and say, hey, I'd love to see the results of a particular test, but I can't make it to the dying, let us know. We'll run it on the dying for you, capture the results, and make sure we publish them for you. We do have what our current series of drives are the G120s. Those G120 drives have been available for 15 plus years. What you see up there on the counter right now is G220. That's our latest version of drive that's in the launch right now. The difference with the G220, there's really three flavors or three variants of that. We have a standard purpose or 6-pole select drive. We have a clean power variant, and that's very important for our semiconductor customers who are going into Europe. So if you guys ever run into a clean power requirement, it's the exact same package size. And then we do have a regenerative version of that drive that also is the exact same package size, so if you ever get into a regen. The other main difference between that drive, this newest generation, as we're launching it, and our current generation, we still have Profinet communications to it. The one main difference that I think is really exciting as we talk about this for the semiconductor industry is that we do go to S2 communications. So that means we have redundant comms. In the past, with our G120 drive, we have a single communication. I have a lot of trust in the Profinet. We have safety on our G120 drives, and if you have safety in a drive, you have to have 100% reliable communications, otherwise all process stops. With that drive, what we've done in the past and shown for the semiconductor industry is if we remove comms, we shut down a processor, we do anything, we hold last state. So we beat it up on voltage, we beat it up on current, we've done all kinds of crazy things to it just to see how it reacts. And that's part of that documentation package, but we've done the same thing with the G220s on that same dime, side by side. So we had 3 variants in this latest test, which there's a few documents we'll make sure you get. With the S2 communications now you got redundant communications, so you can lose a processor, lose a communication channel, unplug one or unplug both. So that's what we'll go through today and show you guys. Really what we're able to do here today is try to build confidence in the network and communication to the drive. We can't do a lot of power testing. I can't do catch on the fly. I can't do things that lock rotor. It's kind of tough to grab hold of a motor and a small 120 volt demo and demonstrate that. But we can do all those tests and have done all those tests. The one thing I'll also throw out there is the communications. There is a default telegram message that is in there for the drive, but these drives can be fully configured. So if you have a particular way that you want all the telegrams to work for your drive, we can create a Micron custom telegram that says here's the information that's important to us, and then every one of those drives can have that same telegram. So ask a lot of questions, stop everybody. This is not a pre-scripted presentation today. This is your session. So we want to make sure that we address everybody's questions.
Cool. Yeah. So I think we'll start by walking through physical architecture. If you guys look at the back, this sheet here. There's a ring coming out of the 2 CPUs at the top. The CPUs at the top are 1500s, but we're adults here, so we use 400s. The ring that is on the diagram goes through 2 I/O racks and then some scaling switches. We don't have the I/O racks in our loop, so we just have the 2 scaling switches. So we come out of the PLC into the scaling switches. Maybe you hit some I/O racks on the way back, but there's a double ring. So this is double redundant right now. So you have you would require 3 sequential failures in order to take down the network, and we'll test that here before we're done. From these 2 switches, we have 2 Ys. So from switch 1A here, we go to each one of the Y switches independently. So that will be our red network, and then from switch 1B, we go to each one of the Y switches. That's going to be our white network. So each one of the Y switches sees both of the main scalants XE206s. The Y switches, and you guys feel free to come up and look at it if you'd like. So I'm not just talking to myself, but the Y switches are ringed together, so that will be the bottom ring on the document. So the bottom ring of the document, I think, has 3 XE206s in the bottom right there. We only have 2 in our ring, but basically starting at this switch, you go from here, we can go into another switch, and then from this switch we go to this switch, and then from this switch we go to here, and then from here to here. So we have a ring here. So you would need, in this particular configuration, in order to lose comms to say this switch here, you would need to have at least a failure of a Y switch and a failure somewhere in this portion of the ring. So that's you need 2 failures in order to disconnect there. From the downstream switches on the tertiary ring, we have a simplex individual connection to the drive. That can also be ringed if there is a desire to do that, but I think the thought is that these switches will be very local to this, and that will be a small network patch cable. So if there is the desire to ring this, that is possible, but we did not do that. We also have a secondary drive for example, and that is the AVB drive on the wall there. So we were asked by Mohammed to provide another drive. We have those, we've worked with those, and we are more than happy to provide pros and cons. So that's physical network. We are running the drive right now in PCS 7. We are using Telegram 352, I believe. Is that what that was, Thomas?
Yes.
And none of our software is licensed, so I'm sorry. We can go ahead and start this at, we'll say 50%. And we'll start forward. There you go. So our drive is running now.
I guess first question, Juan. Is there a way to lock out that reverse option?
Oh yeah. Absolutely. Yeah.
Just to make sure people don't start things.
It's just a checkbox, yeah.
Okay.
And then, if you were using PCS 7, when you do go to stop, there has to be a timeout time. We turned off timeout. Normally there's a timeout time that would be whatever the school down time is on the.
Gotcha.
On the
Can we decide to put how many seconds before it stops, or?
a ramp down time?
Yeah.
Yeah, you can configure that in the drive or in the control system. Yeah, that's just all programmed.
Yeah.
So we are running. So do make note that the fan makes more noise than the drive, so the fan might come on and off. That's not the drive stopping or starting. So let's see here. Where do you guys want to start? So, I mean, I guess first thing we need to understand is what it looks like when it disconnects. So PCS 7 has all integrated diagnostics. So when we pull that, we should get diagnostics coming on the top. You can see that the value has gone black because it's now unreliable. All of our readback values have gone to 0, and we've generated alarms up top here. So I can close this real quick. Move this down low so that we can see it. That's fine. So that's what it looks like when the drive loses connection.
Holding last state.
And it holds last state. So then we reestablish connection.
If it holds last state, like so you pull that and you lose comms, is it put itself in manual or it's just as like an auto lock?
It's just holding last state.
Can I put it into manual seamlessly and then adjust it manually? Like if I had like an incident that ruined my comms and I need to adjust my fan, or or is it a permanent? It's stuck until it has comms established or shut down.
This is like a pre-release something, and it does not have that functionality, but they promised us that it would have that on the next firmware. But currently it is locked, yeah. The G120, you could just resume, you could just take over whenever. This one, when it loses comms, it does hold that auto state, but they said they were going to fix that, so.
It's going to be released in February.
Okay.
Yeah.
Are the switches smart or like noted? So if this got damaged, like it got wet or something happened to it, it went out. I lose this drive and it's still running and locked in. If I replace this with a new one because it's a new switch to reestablish comms, can I do that, or am I still going to have to shut this down?
So there's this no touch configuration on this. This configuration is passed by the CPU. The CPU knows that on this port out of the Y switch and out of this port on the partner switch that this switch should be here and what its configuration is. So when you plug this in, it'll get a name, IP address, and be automatically configured, and the whole thing will come up. So every one of its partners knows its
Plug it
configuration.
in. I like it.
Yeah.
And it'll awesome.
Yeah, and we did a demo. We did a demo for that with Micron, and it was almost frustrating because I was trying to show them. I was factory resetting the switch, and before I could really show them that it was factory reset, it would come back online. So it was
That's great.
It's pretty sweet. And Dylan has already been working with that functionality. Like when the topology is configured appropriately, then not only does it know what belongs next to it, but it also knows when something's missing. So you'll see the switches, the partners fault when something else shuts off here as we go through testing. So right now we're back online. All of our alarms have come and gone.
And you just, that's from the drive?
That's the drive to the switch, yeah.
So you guys, it's already informed the
And
drive.
it can continue to run.
This connection here.
So we did lose comms, which was what expected, but it did stay running, which is what we wanted to do.
Yep.
So I guess the next thing up the chain would be loss of comms on. Well, I guess we'll start all the way at the top and work our way down. But loss of comms between the primary CPU and the scaling switch. So we'll do one at a time first. So you'll see that loss of comms on a port that is expected generates a fault, and we fault here as well. So diagnostics are passed, and with WinCC, obviously the diagnostics are grabbed automatically, but with Wonderware, those diagnostics need to be pulled. But it tells you the part or the port number and the component that is upset. Yeah, not licensed software. And then we can pull the adjacent pair. So now we're running completely on one PLC. The redundancy has failed in this situation. But you can see everything downstream is still happy. You give it some time. And if you look at the alarms here,
Yeah.
the C is coming.
It stayed as master.
I noticed that the other day.
It stayed as master because it's communicating over the synchronization cable.
So into that, we thought we had a scenario once where we were
In
thinking
Profibus,
was
it
doing
cannot.
that. Well, no, at the 400 series through the. Yeah. Right,
Yeah,
sorry.
well, the 410 will do that. The 4 anything else will not.
Okay.
So 417s, 414s will not communicate over the comm cable to reach the I/O. The 410 will. So
And I noticed that on the first
So-
one that we had set up. Because
Yeah.
I thought it was weird, because I'm used to it swapping masters.
Yeah.
And it didn't, I'm like, well, that's a handy feature.
yeah,
And
it
to know.
it will basically the only reason it will swap now is download or like
Or if the
power
other one
off.
dies.
Yeah, yeah.
So how do you know which one's master got me? Or does it matter? It's
It
just the
doesn't
CPU.
matter.
Oh,
Yeah.
Okay. That
It
makes
doesn't
sense.
matter. So on the I/O, you used to see like which one was master. You
Yeah.
don't see it anymore. It doesn't matter.
Okay.
Yeah. So alarms, C is coming, which means the alarm is active. Going means it's gone. So we have resolved all of our alarms. All right, we can continue down the chain. We'll continue to beat up on this network. Unless you guys want to do the same test. You guys want to do the same test on the other side?
Yeah.
Yeah, sure. So we can pull this guy, fault. We're gonna pull this guy. Fault is maintained. And we just get a ton of errors.
Just stays on one. for each other's com card backup.
So alarm is cleared on there. We've almost completely cleared here. IO system loss of redundancy is the last alarm usually to clear. That usually takes a few minutes.
That's not bad.
What?
We were talking about the redundant com cards. We don't run that on ours. Like for your redundant servers, you have 2 com cards each, and we have com cards go out on them.
Yeah, this is actually, I mean, that is a good way to do it. That other converts are my best.
Oh, never mind.
But, yeah. We're still showing loss of redundancy here, but it will probably be okay. We'll find out if it's okay. I'm sure it's okay. So then downstream we have our Y switches. We can start by just unplugging them, I guess. So obviously lost there.
It's between the Y switch to the scans, right?
Y switch to the scalants. We don't have a default generated alarm for that, but if you look down at the VFD, it's still pushing data. Then we can pull the other scalants. I'll wait for that alarm to clear. So you can see it got upset even though its downstream partner was offline. And that alarm is cleared. We'll go ahead and pull this guy. And you can see we're still pulling data, so we still have comms. But you can see that now the upstream switch is upset and the downstream switch is upset. So there's a fault generated. The Y switch unfortunately will not automatically generate a fault until it loses comms completely, which we'll do here in a second. So that's completely back online. And then we'll go ahead and lose both of them.
Both Y switches?
No, we're going to lose both connections to the Y switch. And so we have 2 faults here, still pulling data on the VFD. And since we're going through the other Y switch, we aren't generating faults by default. We can pull diagnostics, and you should pull diagnostics for that kind of situation, but by default, apparently it does not. Which the double Y switch is a new configuration to me, so that is something I'm actually surprised about. I'm sure in the later revisions of PCS 7 it will.
Network monitoring software, would we be able to see that?
You have network monitoring software, so we can see it in real time in a variety of different places. So from the engineering station, so if the engineer was told, hey, we have a problem, the engineer has hardware configuration. This has all the devices in it. The topology is built here. This is how the system knows what's attached where. We can go online with the topology. It usually takes a moment because it does scan every possible IP address in the range.
So this is what you're saying, if you had that issue, come here first and help you identify what's
You could do
going
that. Maintenance station should have a view like this that could show you what's wrong as well, so you don't even need to go to
If there's an interruption in the signal, it show you red between, for example.
Yeah, we'll do it
scans.
right now.
Okay.
So everything looks good right now. The CPU is faulted because the CP cards on the ends are not connected and don't have communication. But everything else is talking. If we fault something, which this will be let's do this. The next thing I wanted to test was power off on the Y switch. So we'll go power off to the Y switch. And then we can update here, and it'll take a moment. On the OS side, it uses the alarms to identify what has failed, so it doesn't have to do this like scanning update kind of deal, but the end result is the same. So there you go. So we've lost communication to this switch, and then all of its subordinate connections have gone red. And then anything that's plugged into that switch is also showing a fault.
No, that would be
Yeah.
awesome.
So we have faults on everything associated with that switch. So this switch, obviously the switch is down, and then these two switches, because they're missing their partner and they're lonely and sad. Yeah, we're still running and we're still pulling data. So we have not lost comms except for when we pulled that guy. So we can power the Y switch back on. And this does take a few minutes to come back because the MRP ring is it takes some dancing for it to get on. And this is our MRP master. So in any scenario, any ring scenario, you have to have a master. In these rings, our CPU is the master, and in this ring, this one right here is our master. So we lost our master just now, and it seamlessly transitioned over to the adjacent switch as for the master. So and we're still showing a fault on that. Once it clears, we'll there we go, and all of our alarms have come and gone. So we should be good to go there. Cool. Do you want to do the same thing on this Y switch?
Can I update it?
Oh yeah, go ahead and hit update. Yeah.
Just want to make sure
Yeah,
everything
yeah,
is
yeah.
back online.
Yep.
So how'd you set up the two different masters?
There's only one master.
Yeah, it's that one.
This one is the master. But if you look at your MRP domain, the list,
Yeah.
the one that is master is just the first one. It will go to the next one in the list, and that's not master. Yeah. So that order does matter. I guess. I mean, it doesn't matter really, but
If you have those idiot.
yeah, if you really want this to be the master, because I mean this. If
Doesn't
this
really
could have
matter.
taken over, this couldn't take it, they would have all done it the same way, right? So like whatever. But if you maybe didn't want your IO rack doing it, then sure. Yeah. Do you want to do this one as well, or is it? I mean, it's the same thing. So we're gonna go ahead and lose the upstream connections to this guy. So we generated some alarms there
This is the second Y switch,
because
right?
yeah. So because this is the one it's talking through, it actually did generate alarms. So it had to fail over. So we actually got an alarm there, but we're still communicating. Everything looks happy. And then we'll wait for that to come back. Clear these. They're good. And then the alarms have gone. So we can clear that. And then, so we're good here. So we're gonna go ahead and lose this upstream connection. And we did generate faults because that is it is using this Y switch actively. So this one is standby, which is why we didn't get faults on that guy. But yeah, I'm fairly confident in the later revisions of PCS 7 you'll get alarms for both of them. But double Y switches are a new feature. So still pulling data, definitely just unplug. Plug back in.
Even if we lost both Y switches, still we're gonna get pulled data and it's lost.
No, if you lose both Y switches, you're physically disconnected. Like that's an air gap here. There's no connection from here to here without the Y switches. So you can lose one Y switch or the other Y switch. That's fine.
But the drive would still hold us.
The drive runs anyways. Yeah, we can power both Y switches off if you guys want to see that.
No, because in that case right there, if you had IO connected to it, you're gonna lose it.
Yeah, if you had IO connected, you're losing it either
Doesn't
way,
matter.
right? If you lose two switches, you're probably. I mean, you got a guy on a forklift going crazy. Because these are going to be in, if these are in separate panels on separate power, then.
That's what I was gonna say, we put these in separate panels.
Yeah.
Throughout the
Yeah.
plant.
And don't forget, you're gonna be UBS power.
drive-
Anyway, you're gonna be
Yeah,
on
yeah.
them, so.
Two redundant PLCs will be in different panels.
Yeah,
Correct.
sure. So,
You pull the two switches on that from the upstream to like as it's break, and you pull one from the other one. It
sure.
should still be, I mean, functional,
Yeah.
right? 'Cause
Yeah,
you
we
still
can do
have
it.
one segment going.
We can do it, yeah.
That's
Triple
a good idea.
failure.
That's a good idea.
Yeah, triple failure.
Yeah.
I'll pull this one.
It's what we've been on it. We've had the issues where
So-
only one of our rings had one segment.
We're still pulling data, and we're triple failure. Yeah.
Switches. So one is the hold last stage. And
Yeah. So you can't.
Simple.
Yeah, still pulling data. Still pulling data.
So it
Yeah.
wasn't holding that.
We're not holding last state. We're still. I mean, you can ramp the drive up and down.
Yeah.
You still have full control right there.
One segment.
Yeah, through one segment.
This is updated because
That's how we do our
definitely
pumping bus
the
rings.
some of this is the one
Or
that
the
is done
three phase. You just cut anywhere you want
I
on the
would
ring
hope that we
3
can
times.
actually get some diagnostic.
Use it.
Yeah. Well, the diagnostics are there. Like it's generally so. Yeah. So if we look at.
It's just the running on the main one and we don't even know.
Yeah. So. Right, and that is very important because that's the biggest problem in redundancy, right? Is that people lose the redundancy and they don't even know, right? So, yeah. So this is PCS7. Everything is pre-built. Like we didn't build any of this. And this version of PCS7 was released before double Y switches were available, so it was not built in anticipation of that. The newer version, I'm assuming, will have anticipation for that. But if you look at the switch itself, it has diagnostic data. Oh, and I can't monitor it, but this is its diagnostic address. So this data is going to be generated, and those diagnostic alarms will come in. But since you guys are using Wonderware Anywhere, it's the responsibility of the Wonderware engineer to look at those and then build the alarms based on that. Yeah.
So there is like configuration or to integrate we can receive alarm or
Well,
messaging if we get
it's-
lost the connection here.
It's here. So these addresses are in the PLC. No matter what, like you can't put the switch in without generating the diagnostic addresses. Like it does it automatically. So then it's the Wonderware engineer's responsibility to go in there, take apart the data, and build those alarms for it.
And we can do that in Aviva system.
Yeah, Aviva. Yeah. So you have to do it.
Therefore, you add an extra one.
And we don't do any of that work because that's just a bunch of nonsense. So like it's just done for us. Yeah. All right. So our triple redundancy, our triple failure is complete. We failed the Y switch off. So then the next thing to fail would be a partner in the ring. So we can start by just disconnecting the partner.
Which one?
That would be like this guy.
Okay, so the ring here.
So I'm gonna break this. Yeah. So we break the connection in the ring. The switch fails, gets very angry, but there's still communications to this. Like if there was a device plugged in here, we would be okay. So we put it back.
As long as the man can go below those two that lock.
Let that air mouse go. Cool. So then we're going to break the signal coming to, so it would be this one right here. So this is the switch running the drive, so it's going to lose its immediate connection to its Y switch.
You may lose one. That's how we
And then we come back. So the switch failed.
Wait, you fill those two and you still
No,
have
no, no,
those?
no, no. Fill this one first.
Oh, put it back and then
Back.
fill the other one.
Yeah.
Okay. Go both ways around that.
What's gonna be happening if we double fill it on both sides?
Oh,
You
you
fill-
lose, yeah.
we
These?
lose- Yes.
I mean, you'll lose comms, but it'll stay running.
This one running? Okay.
I mean, you want to do that?
Yeah.
Why not? Why not?
Just
So,
just
we'll
like, you know,
lose
worst case scenario, you know?
this guy, and we lose this guy. So now these switches are isolated. Our data has gone to 0. We've lost data here, but we're running in last state.
So hypothetically, like, so one thing we do at least on our side a lot of times, and I don't know if ID1 will have this, but we have to add on or tie into stuff or add new on existing and running.
Yeah.
Let's say somebody was doing this because these are smart and they got plugged in the wrong spot.
It will run, but it'll be faulted.
Will it auto like try to like change its, because isn't it address itself based on
Yeah,
who's
because
up and down?
It won't automatically address.
It-
So
okay.
because
if you manually configure, so if I went in and configured the switch manually, but then plugged it in wrong, it will work, but it will be faulted,
Okay.
but
I can
it'll
still have
work.
controls.
Yeah.
Yep, it'll still
Okay.
work.
So,
Yeah.
because those managed switches and each port, we have to ask IP addresses for it.
Okay.
You know? So if you put it in wrong, ports, still gonna be receive faults, but it still has control on
Okay,
Yeah.
and it still knows what
And
that
it still-
is. It
exactly,
still knows.
exactly.
Yeah.
Does it know where it is at that
Yeah.
point?
Because most of the IT, they have to know which port those is gonna be connected
To
to.
assign to.
There is
Yeah.
a cable schedule or something,
So-
okay, maybe technician here gonna do one mistake and still full, but you
Yeah.
can't troubleshoot it and you can't figure out
Would
which
IT
port.
be running this network?
God, I hope no.
Thank you.
No, but the
I don't know when you do that.
IT will gonna configure the ports. They give
All the
But
ports,
SCADA would
all the
configure
ports are
these.
configured in the
Yeah.
engineering station. All ports are configured. So you configure here, and then you just plug it in, and it just takes off. Like if it doesn't just take off, then something's plugged in wrong. I need to fix it. But like,
But it doesn't have like a
You don't need to do
mismatch
anything.
where I feel like I'm the same node as someone else, both of us stop.
you shouldn't ever be. No. So we don't. So
That's right. That's what
very
we have
important
right
thing
now.
is that IP conflictions do not take down these networks. It's not like an Allen Bradley system. IP confliction and like your whole plant goes down, right? That will not happen here because primary communications are done via MAC address.
So, but if so, like right now, I know that for our like ET200M, if you have two nodes the same, if you have a running node and
Oh.
you commission another one,
Yeah.
you lose them both.
Yeah.
So if that's like manually set up addressed to be that switch that's the same address as another one, does that?
It won't stop control.
Okay.
Yeah. It makes, like when you're trying to configure and scan the network and stuff, because you can scan this network with Proneta, which Rainwater's been using a lot, and it will show this to you. It will show you what's plugged into what everywhere. Can you pull up Proneta while we're talking here?
Quick question.
Yeah.
If we're gonna have interference, do we still have running?
We have interference set up for you. We're gonna have an
Okay,
interference
perfect.
test.
I need that too.
Okay.
Yes.
So I think we've failed everything, right?
I guess
Anything
so,
else
yeah.
you guys
Yeah.
want to test?
You guys have a question?
Anything else we want to break?
So I just imagine what's the length you can run these, keep them apart for these? Is it just Cat 6, real Cat 6?
Well, yeah,
100
it's just
yards?
Cat 6, but you can replace these with 5. I mean,
They
every
could,
one of
if
these.
you had to like send one out to a well house or something.
Yeah, any one of these modules can be replaced with these are the RJ45s, but you can have RJ45 to fiber or fiber
Okay.
or
so you can
whatever
extend
you
out
need.
with fiber.
Yeah, and then these right here, they have the SFP ports, so you can have 2 fiber ports per switch
off
here.
Okay.
Yeah, or whatever you want there.
For ID1, it's all set up for
Single mode fiber.
so all these like those switches. This one hang off of that range.
Yeah, these are.
Okay.
It's an
But
SFP,
in
so you can
theory,
insert
downstream
whatever.
why-
You can put RJ45 in there if you wanted. You can put multi-mode fiber, single mode fiber, long distance, short distance, whatever. whatever you need to put in there.
So for the white switches, you have to order it with fiber. You cannot just do the SSP on it.
I'm sorry.
Sorry, for the white switches, you say that it comes with fiber, right?
You can if you want. So you
have
can
to
replace
order-
this module.
Yeah. Oh, fiber modules.
Yeah, this module right here comes out.
Okay. Then you
These
use
two
fiber
right here,
optics.
and then you can put fiber in. So you can go copper fiber right here. So you don't need a media converter.
Oh yeah.
You never need a media. So you can come in fiber, leave, or come in copper, leave fiber, or other way around, whatever you need to do.
Still is one of the concern.
Okay, so we wanted to run noise.
Yep.
So where do you want to put?
That's important part, okay?
This is our noise generator. So we have a.
Apply noise and see what's gonna be.
So we have I think a 1500 watt heater down here,
Okay.
and it is coiled around our cable to generate some EMF for us. Do you know where you want to stick it? Where do you want to put this thing? This is just kind of the easiest place for me to put it, so I'm going to put it here.
Scale, white switches.
Yeah, right here to here.
So we're gonna put now interference to it and see how we're gonna do it.
What kind of interference? Noise?
Yeah, noise.
Yeah, EMF.
Yeah.
Nice little EMF noise. So, the electromagnetic field generated is primarily based on current. So we're going to be pulling like 14 amps through this line here to hopefully interfere with this. So we have comms established, and all of our alarms have cleared. We'll see what this does. So we're going to turn our heater on. Tom's going to make sure that's all the way up here, but we're pulling right now 10, 11, 12, 13, 14 amps, 15 amps. So 15 amps, if this was a 480 circuit, I mean, you got a fairly substantial motor there. We're coiled around the Cat 5 cable, which is coiled within that. So this should be a pretty solid electromagnetic field right here. We should have a lot of noise going on. We haven't generated any alarms though, so we haven't lost comms here yet. What's that?
Is there a way to see like packet counts?
There are, but if we lost packets, we would get an alarm. So we could dial in the switch and see it. But it hasn't even, I mean, it should generate an alarm if it sees anything, so. Our coil's actually getting warm.
Did you roll a little?
Yeah, it just, this is like worst case scenario for communications. Like,
Yeah, I
if
think
you had
we-
something that bad, someone needs to be taken out the back shot. So.
We could probably run it, like I said, on the Vine, we could probably run it around the AC and the DC lines with the bigger motors and
Right.
really see. But I mean, contractors do crazy things, not
39. Well, they did it with the boilers.
Do you have
They
something
wrapped the
to
480
generate
around the
vibration?
Yeah, so we can, like physical vibration?
Yeah, physical vibration.
Yeah, wait, I was gonna bounce this on and off a couple times.
Is it's just like the Profi bus where you have the fast connect. You have the same thing with
So sometimes, you know, those
fast
come near
connect
to
and the connectors.
pumps or sure, you know, those are gonna be
Sure.
alarms, vibration and noise, so
You know,
just make sure you need to
Yeah, hopefully the crossing 480.
see the
not
test,
running
if
with
that
it,
is
but,
loud vibration.
At the start of the commissioning, you also pick up, noise installation. If they're running it through conduit 480.
So,
you probably
15 amps in a really, really bad EMF field, no alarms. So I would assume that's no packet loss, no interruption in the signal. So if we disconnect though, immediately we get an alarm. So you want to do physical vibration?
Yeah.
I don't know that I have anything other than I can just pick it up and shake it. Ready?
Yeah.
We got some alarms. I broke something at some point. We're still getting communications. Looks like something came loose at some point, but we never lost the drive. Well, drive maintenance demanded.
I was still data.
Maintenance demanded. Motor protection triggered. External error occurred.
Can't stand up to an 8.5.
Yeah. And honestly, that's probably more install than anything. I mean, I don't know. I mean, you're gonna jiggle wires loose.
Yes.
Yeah.
You did,
No.
you did it widely.
I did it pretty well. I mean, I honestly am surprised we saw anything, but
We do definitely have vibrations.
drive
Yeah.
warnings,
So,
standard limited,
In some
group
scenario,
error.
you're gonna have some
Motor
noise.
That was for the ADB one though.
I think.
Yeah, to do the G220.
Oh. Oh wait, no. Drive 220 group error. Needs demanded. Oh, these alarms came from the drive.
This is from the ABB, right?
These two came from the ABB drive, and this one. So this is actually a good example of this. So what's really nice using Siemens VFDs in the Siemens system with the drive's ES block, which you can use in PCS 7 or in Step 7, you get the alarm code. So this alarm or this warning or whatever it is will come up with the actual code as it does on the drive. So the operator can provide the technician the exact alarm code before the technician gets out there, so the technician knows exactly what's going on with the drive before they show up. Additionally, because the drive is on the network and we have a service bridge plugged in, which allows us access into the I/O network. Are you logged in?
Yep.
Thomas can go online with the drive right now and see what that alarm is. So, you know, if somebody was like, hey, I got a problem with a drive, an alarm came up, without getting out of your chair, because we know how much, you know, those INC guys like their chairs.
Wow.
You can see what's going on. You can see what's going on in the drive, because there really shouldn't be any reason to get up, because, you know, we service customers that have large plants that don't have INC guys. Maybe they have a general electrician, and so they'll get this alarm and they're like, hey, what's wrong with my drive? And I don't need to go there. I don't need to look at the drive. I don't need to touch it. Like, what are you gonna do when you look at the drive and open up the bucket? Like, I mean, what are you gonna do? You're gonna plug into it, right? It's all, or flip through the menus. Like, it's all you can do. You're not gonna like pull out your screwdriver and jam it in there and fix something, right? So, if you can tap the drive with it running, with the bucket closed, and see exactly what's going on in it. So we have a
Second controller missing.
second controller missing. So it lost one of the paths to the one of the CPUs. So you can say that and then be like, well, I'm the VFD guy. That's not my problem. Acknowledge alarms. So, what's that?
Clears it's no problem.
Well, yeah. I mean, like I said, nothing in PCS 7 ever goes away. So, let's see here. Which one is it? Outgoing alarms. No. Acknowledge alarms. Close that guy. Yeah. Everything is always there. Nothing ever goes away. Operator list, yeah. I think that's. I should be able to see all of the alarms. I don't know. I usually look at it from the engineering station, so I don't really know. Where's acknowledged alarms? Yeah. Either way, yeah, that's what we got. So we have the ABB drive. We do have a little bit more sensitivity with the ABB drive. The ABB drive is not compatible with MRP rings, and ABB has not been able to resolve change and run. So we can go ahead and turn on our ABB drive. Let's see, where are we?
What do you mean by changing from?
So,
Like change the set point.
No, not change the set point and run. So if I wanted to add a drive and run, if I wanted to delete the drive, if I wanted to change the part number on it, that is a CPU stop. Yeah, it's not great. But here's another feature for, well, I guess I don't know. You guys hardwire 7 points. Just reset one of those points that you guys?
No, it's this. Yeah.
Oh. So one of the awesome things about the network is reset. So you do get reset. ABB drive or Siemens drive. So on the Siemens drive we have, this is drive TS, so we can use diagnostics. You can see active fault codes. This is the G120 faceplate. This is a G220, so we can't pull. Normally you can see all kinds of extra data here other than just reset, but the 220 did not seem to cooperate with the 120's block. So in PCS7 we're still waiting for the 220 block. Or maybe my drive ZS is out of date, I don't know. So ABB VFD is going to be a little bit more sensitive here. You go here, forward, and okay. I'm sure it can be done, but we were not able to figure out how to make it run or hold last state. So if I unplug this, it will shut down. I don't know if you guys want to see it?
Yeah.
Sure. So
I don't think it shuts down until we plug it back in.
oh, yeah, that's even worse. I mean, it does whatever it does. Okay, yeah, so it's just looking for rising good. So stays running. Yeah, and then did it hold last state? Did we get it to work?
There it goes.
Oh, no, we didn't get it to work. Yeah. I'm sure.
There's a way to.
I'm sure there is. I mean, it's just drive configuration, but we weren't able
Maybe
to.
some parameter needed to.
I'm sure. So that is that, and then there are problems with its MRP ring compatibility. So I'm going to start it again, and I actually don't know. So, I'm going to break this guy, and we're still talking, so it should be okay. Trying to remember exactly what made this fault, and I haven't actually seen it on the double ring, so it may be better now, but I actually have a customer running these, and he has some complaints about them. I asked him if we could call him, and he said yes. So if you guys want to talk to him about the problems,
The ABB?
pluses and minuses, yeah, I mean there are advantages to them. They are very easy to set up, but you know, complexity is functionality.
So only the connection between the drive to the scalons. If we disconnect it, we're gonna lose the
Yeah, I think.
How about other connection?
I think there is. Let's see who's master. So I think if we lost this guy, we may lose it on return. Maybe. Our biggest problem with them has been on the engineering side. On the engineering side, they have not been as compatible as advertised with change and run. So changing the program around them does cause problems. I can demonstrate that. So if we are in hardware configuration and we wanted to add one of these, if I drop one in, it gives me a warning, well, it's the PDM warning, that this product is not compatible with change and run. So it's the high availability, change and run compatibility. So ABB has not been able to resolve that as far as I know. We have a customer running 3 plants with 3 MCC banks of these, and they've been asking for it.
They're not very happy about that.
They are extremely unhappy about it. So
So overall, we can say APP not gonna be compatible with this network.
as of right now, yeah. Yeah, and I don't know what the other options are right now. But I would recommend, because ABB said it was gonna work, and then it didn't. So
Can we use it in different drive?
I don't know.
How about
I would test it because they said it was gonna work, and then it didn't. So yeah, Yaskawa, I mean, whatever you want to try. The disadvantages you're going to find with those drives is pretty good. Like I was saying earlier, the telegram is very limited. So on that drive, we can pull back 1 additional value. So we have the read back here, right there. With the Siemens telegrams, we're pulling back 3 values on the faceplate, but if this was a 120, you could open diagnostics and see like line voltages and
For the start, it's just a graphic color, right? It could be red. Sorry, I know it's a silly question, but our whole site is red running.
This is
graphic.
This is not your system, yeah.
I thought that was like the Wonderware.
This is
PCS
Siemens.
graphics.
No,
Yeah.
this is Siemens. Yeah, this is WinCC. This is not Wonderware.
Well, okay, I know that. I'm sorry. I thought this was the new graphics.
No. That's Wonderware. This is Siemens PCS 7. It's like a totally different software package. Like from the engineering side all the way to the graphics is a different package.
These are the default configurations.
Yeah.
Where I'm wondering where you guys got your own standards.
This is ISA and IEEE standards. Yours are just nonsense.
Red danger running.
Right.
Red danger hot.
Besides ABB drives, have you tested NFOS?
We are not aware of any other drives that are R1 S2 compatible. Which means they have, with one cable they can take a signal from redundant Profinet masters. So we have not. I know there's supposed to be a whole lot of them coming, but we haven't seen them yet. So
in the case that if you were to put in the specs, you have to specify that it has to take redundant.
R1 S2 is extremely important, and the sales guy is going to just ignore it and give you a spec anyways.
Yep.
But it is so important that like R1 S2 has to be R1 S2. If it's not R1 S2, it will not work.
Well, and compliant with
And MRP compliant. If you want to do this, you can get away without MRP ring if you don't want to use an MRP ring. But if you want the reliability and redundancy that was presented today, then it has to be MRP, because this has 3 MRP rings in it, and if your device doesn't support MRP, then it's going to be a problem.
And compatible with CIR.
And CIR.
Yes.
Change and run, yeah. Profinet CIR, yeah. Configure and run, change and run.
So as for now, the only gonna be working in single G22.
G220 and S and the S series as
S
well.
series.
Yeah, the S series and the G220s.
Not gonna be for now compatible with that.
For now, yeah. ABB said like a year or 2 years ago that they were gonna fix that. They still haven't. So
Been that long.
yeah. I mean, the MCCs were purchased. The problem was found. They were installed, and we were like any day now. And the plants were commissioned and are running, and still not. Yeah. Yeah. I don't know. I don't know what's going on there.
You can't stop recording.
Yeah.